Good morning. This class today we are going to discuss straight lines. The topic you have started probably from class 8, in class 11 also. We are doing it because this is included in your syllabus where you have to know equation of straight lines and you have to solve problems accordingly. Without wasting time, let us start to discuss about a straight line. But any discussion on straight line will be possible by knowing the slope of the line. Let us know what is the slope of a line. In any coordinate system, the slope of a line, it is two-dimensional coordinate system obviously. The slope of line is defined as the angle made by a line with positive direction of x-axis. That slope is going to be m equal to tan theta, tangent of the angle made by it with positive direction of x-axis. So if you are asked to find slope of a line whose inclination with 45 degree, then its slope am is going to be equal to tan 45 degree. Tan 45 degree is 1. If am is equal to say 120 degree, then tan am is tan 120 degree. Its value going to be tan 2 into 90 minus 60 degree. The angle lies in second quadrant. Second quadrant tan is negative. By using this concept, all sine tan cos. Add sugar to coffee. So by using this concept, it will be minus tan 60 only, and this is minus root 3. Slope of the line is equal to minus root 3. So slope of any line you can find in terms of the angle made by it with positive direction of x-axis. Take another example. Suppose this is not m. We have taken theta equal to 120 degree. Now suppose theta equal to 135 degree. Then m is going to be what? M will be equal to tan 135 degree. This is nothing but tan 1 into 90 plus 45 degree, that is minus cot 45 degree, and value is equal to minus 1. This way we can find slope of any line by knowing the inclination of the line with positive direction of x-axis. Now, is it possible to get the slope of a line in terms of point on it? Suppose a line is there, on it 2 points are given. Points are x1, y1 and x2, y2. Draw perpendicular here, AL, and this is another perpendicular, BM. Draw this perpendicular also. This is AR. This is your origin. This has coordinate x1, means OL. This part going to be x1. OM going to be x2. This part y1, and this whole thing BM is going to be y2. Then slope of the line, by definition, tangent of the angle it makes with positive direction of x-axis. So this angle is also theta. Now slope is equal to tan theta. Tan theta is nothing but BR by AR. What is AR here? BR, you all can see that BR is nothing but BM minus MR. What is MR here? MR is Y1 and BM is Y2. So this part is Y2 minus Y1. So numerator is known Y2 minus Y1, and the value of AR is going to be, you all can see the diagram, that AR is LM, which is nothing but x2 minus x1. So slope of the line going to be y2 minus y1 by x2 minus x1. Okay. So slope of the line can be determined easily if 2 points on the line are known. For example, if it is given that 2 points are as 2, 3 and 3, 6. What's the slope of the line? That AM will be equal to y2 minus y1. This is not true that I have to take this one x1 y1 and this one x2 y2 always. We can change also. Taking say this one x1 y1, this is x2 y2, then also it will work. So y2 minus y1, I am taking this part x2 y2 and this is x2 x1 y1. So this is 6 minus 3 by 3 minus 2, that is equal to 5 by 1. So slope is equal to 5. What will be the slope of line which passes through origin? Passes through origin means origin is a point lying on the line. So if any point given over there, suppose the point is A comma B, then slope going to be tan theta, which is nothing but B minus 0 by A minus 0, that is B by A. Slope of the line can be determined by this method, by knowing 2 points on the line. Now, while discussing slope of line, the question arises here, can we define slope of line which make obtuse angle with x-axis? Yes. The method is same like previous one. This angle with positive direction always we take into consideration. So if this angle is theta, AM will remain the same, that is tan theta. Already I showed you by taking example of theta equal to 120 degree and 150 degree. Sometimes problem may arise this manner. What is the slope of a line which slope of this line which makes an angle say 30 degree with positive y-axis. This is not a problem here because if we take this on 30 degree, then this angle can easily be determined. 30 means this one 30. So this is 90, this part going to be 60 degree. So AM is going to be tan 60 degree. Tan 60 is nothing but root 3. So slope of the line is equal to root 3. AM is equal to tan 60, that is equal to root 3. That's all about slope of line. Now, in this class 11, you need to know what is a line actually. A straight line or line, whatever you see in coordinate geometry, this is actually locus or point which satisfy the first degree equation. What does it mean? That equation of line is always represented by a first degree equation. First degree equation is like this in two variables, ax plus by plus c equal to 0. It will always represent a straight line in two variables. This one represents a straight line in two variables x and y. Okay. So any point which satisfies this line, plotting you have the idea already. You are doing it from class 9, I think. This is a line. So this line has equation ax plus by plus c equal to 0. What does this mean? It means any point on the line will satisfy this condition. So if there is a point, say alpha comma beta on the line, then this line will be satisfied. It means if you replace x by alpha and y by beta, a alpha plus b beta plus c is equal to 0. This is the condition has to be satisfied if a point alpha beta lies on the line. Never forget this. If a point lies on line, it must satisfy the equation of the line. Now, we can prove that if there are 2 points like P alpha beta and Q gamma delta, then any point on the line segment joining these two, here, it may be here, it may be here, those will satisfy the equation of line. Okay, let us take an arbitrary point here. This point be Pxy, which divided in the ratio, say k is to 1. Then its x coordinate going to be what? K alpha plus beta by k plus 1. And y coordinate is k beta plus 1 by k plus 1. Now this is the coordinate of the point. No, P already taken. You take this point as R. This is the coordinate of the point R. What you have got? We are going to prove a very general concept about the line, where if 2 points are known, then on a line, then any point which divides it internally at this moment, it may be externally also, will lie on the line. Let us prove it. We have taken the point alpha beta and another point gamma delta. Rxy is a point lying on it. By using class 10 section formula, we got x equal to this thing, y equal to this thing. Now the question is, do they satisfy this condition? K alpha plus, wait a minute, it is K alpha, I wrote it wrong, it will be K alpha plus gamma by K plus 1, y is going to be K beta plus delta by K plus 1. Okay? So this point must lie on the line. The condition you got, alpha beta is a point lying on the line, so the condition is valid. Gamma delta, if it lies on the line, this condition will be valid. A gamma plus B delta plus C equal to 0. This is your number 1 and this is number 2. So these two conditions are always known. Let us see this P and Q, when they satisfy the equation of line by obeying these two conditions, whether this point which lies on the line segment joining these two lies on it. So we are going to state a general concept here. If 2 points lie on a line, then any point which divides the segment joining these two internally or externally, that also we are going to lie on the line. Let us see. If I replace x by k alpha plus gamma by k plus 1 and y by k plus 1 plus c, then you take the LCM, k plus 1 a into k alpha plus gamma b into k beta plus delta c into k plus 1. All of you understand? By taking k plus 1 LCM, we are getting this. And then from these three first terms, first term means ak alpha, bk beta, ck. If we take k as common, it is a alpha plus b beta plus c plus a gamma plus b delta plus c by k plus 1. But alpha, beta and gamma delta was point on the line and they are obeying this condition. This is second condition. First condition all of you can see. So what is going to be? 0. Okay. So this point will satisfy the equation of the line ax plus by plus c equal to 0. So any 2 point you know on the line, it is known that it is established that any point on the line segment joining these two will lie on the line. This is a general concept. Okay. And another thing we should remember that this equation always represent a straight line ax plus by plus c equal to 0. Okay. This equation. It is a straight line. Any first degree equation in 2 variables, maybe in 1 variable also, will represent a straight line. Now, after knowing the slope of line, question arises, what is the use? How do I use in class 11 maths or applied maths syllabus that will help us to study the two-dimensional coordinate geometry? I am going to explain. Slope of line, all of you have the idea. Suppose I have taken 2 lines this manner. Lines are like this, x, y. This is their point of intersection. This line AB makes an angle theta 1. This makes an angle theta 2. And angle between 2 lines is equal to theta. Your problem is to find this angle theta between 2 lines. How to? We just use the concept of slope. Slope of first line M1, all of you can see that in the diagram it is tan theta 1. M2 is equal to tan theta 2. And it is also true that this exterior angle is sum of 2 interior opposite angles. So theta 2 equal to theta plus theta 1 in figure. Okay. So theta equal to what? Theta 2 minus theta 1. And this will help us to get the value of this angle. How to? You take tangent of 2 sides. Already I have explained this formula which you need to know, but right now no proving is required. Just remember this gives us tan A minus tan B, that divided by 1 plus tan A into tan B. We are going to use this. So if you take tangent of 2 sides, because I need tan theta, this is going to be tan theta 2 minus theta 1. So this is nothing but tan theta 2 minus tan theta 1 by 1 plus tan theta 2 into tan theta 1. This is the formula. What is tan theta 2? I have written there, it is M2. So this is M2 minus M1 by 1 plus M1 M2. Therefore, theta is going to be, you keep it in this manner, better. Okay. So angle between 2 lines you can determine by using this formula. Tan theta equal to, actually it is mod of this. It may be positive, may be negative. We don't know, but we need the positive value always, because angle between 2 lines normally people say in terms of acute angle, not in terms of the obtuse angle. Never say that it looks like acute angle, so that theta we can determine from this relation. If a question arises, suppose a line has slope equal to root 3, another line has slope 1 by root 3. What's the angle between them? If we take M1 equal to root 3, M2 equal to 1 by root 3. Just substitute there. It is mod of one plus 1 by root 3. So this is nothing but root 3 is the LCM. 1 minus 3 by 1 plus 1. So the answer is This is minus 2. By using mod sign, it will become plus sign, all of you know. 2 by 2 into root 3. So this is 1 by root 3. Therefore, theta equal to tan inverse 1 by root 3. This implies theta equal to, what is tan inverse 1 by root 3? That is, or you don't write 1 by root 3 because you will be more confused. You leave this habit of writing inverse. I want to avoid initially. Once you know the inverse trigonometric function, you must. So tan theta is 1 by root 3. You know the angle whose tangent 1 by root 3 is 30 degree. So this is tan 30, theta is going to be 30 degree. Alright. So the angle between these two lines is equal to 30 degree. I think all of you understand. After knowing angle between two lines in terms of their slopes, it is better to do some further analysis on the result once. You all can understand now that if two lines have slopes m1 and m2, then tan theta, tangent of angle between them, is given by m1 difference m2, that divided by 1 plus m1 m2. Okay. So angle between two lines we can get by this formula. Now the question is, what will be condition for which two lines are parallel? Two lines should be parallel if theta equal to 0 degree. So lines are parallel if theta equal to 0, that is m1 difference m2 equal to 0. So m1 is going to be equal to m2. No problem. So two lines are parallel if their slopes are equal. It's a concept you should keep in your mind. Lines parallel, then their slopes are equal. Lines perpendicular under what condition? Lines are perpendicular when under what condition? When theta will be 90 degree. Tan 90 degree means something by 0. So 1 plus m1 m2 equal to 0. Therefore, product of slopes will be equal to minus 1. This is very easy to remember, and this is one of the pillars of coordinate geometry where you understand the slope concept, the angle between two lines concept in terms of slopes in both the cases. Okay. So lines are perpendicular if m1 m2 equal to minus 1. But I did not tell you how to find slope of the line. We will definitely solve some sums. Wait. Next, we are going to know different forms of a straight line. Now let us see how the concept of slope helps us to solve problems on straight lines. Concept of slopes can be used to prove the perpendicularity of two lines, parallelism of two lines, whether a triangle is right angle or not, whether a given diagram is a parallelogram or not, whether points are collinear or not. Let us see one by one how the concept of slope helps us to solve this kind of problem. First one, so that the line joining this and this parallel to this. So what we will do first, we will find the slope of this line, this one. What is the slope here? That we take m1, y2 minus y1 by x2 minus x1. So this is going to be minus 5 minus 2 minus 4 by 7. And slope of this line is what? m2 equal to, again y2 minus y1, 3 minus minus 1 by 0 minus 7. So we got 4 by minus 7. Since m1 equal to m2, the two lines must be parallel to each other. Line segment joining this and this will be parallel to the line segment joining this and this, because they have the same slope. The concept is already explained to you. Two lines are parallel if they have same slopes. And the concept of perpendicular line is product of slopes must be -1. So let us find the slope of this line. This M3 is going to be -2 -5 -7 and 0 -4, that is -4. It is 7/4. Now the third line is parallel to both the lines M1 and M2. What way? Because the product of slopes -4/7 into 7/4, the result is -1. Okay? Since product of slopes -1, the line segment joining first and second will be perpendicular to the line segment joining third and fourth. Alright? Now, how to find the value of x if the slope of line segment joining two points are known? This is very simple. Determine x if the slope of line joining this and this is equal to this. What is the slope of this line? 3 - 5 by x - 2 will be equal to 2. -2 by x - 2 equal to 2. So x is equal to 1. To prove this kind of problem, whether they are vertices of right angle triangle, three vertices are given, you find the slope of any side in pairs, and from there you can get it quickly. Let us find the slope of, to prove number 3, we are going to find slope of the line segment joining this point and this point. See part 1. Take A as 12/8, B as -2, 6. For the slope of AB, I am writing the slope as MAB, 6 - 8 by -2 - 12, -2 by -14, 1/7. For the slope of BC, 6 - 0 by -2 - 6, -3/4. Their product is not -1. MAB and MBC, their product is not -1. So we cannot say that the triangle is right angle so long we don't calculate the slope of AC. Let us find MAC, 0 - 80 by 8 by 6 - 12. This is nothing but 8/6. All of you can see this slope is 4/3 and slope of BC is -3/4. Since slope of AC into slope of BC is -1, therefore AC is perpendicular to BC. If you draw the triangle ACB, this angle is 90 degrees. Similarly, to prove these are the vertices of parallelogram, you just use the concept of slope. Distance formula you already used. The distance formula was there in class 10 course. All of you are familiar with that. But without distance formula, just by using the concept of slope, we can get it easily, nicely. How to? Just for this one, you take the first point A as 4, 5, B as 1, 2, C as 4, 3 and D as 7, 6. If there is a parallelogram like this and these are the vertices, you need to prove slope of AB equal to slope of DC and slope of AD equal to slope of BC. If we can prove this, then it's fine. So let us calculate slope of AB. Slope of AB is what? 2 - 5 by 1 - 4. slope of BC is 3 minus 2 by 4 minus 1. Slope of CD, this is 6 minus 3 by, so this is going to be minus 3 by minus 3, 1. This is 1/3. This is 3. 3 by 3. No, this is 1. 1. So we found slope of AB, BC, CD, and then let us find slope of DA. Slope of DA will be what? D is this, A is this. So there will be 6 minus 5. So 1 by 3. So you can see that DA is parallel to BC and AB parallel to CD. Why? They have the equal slope. 1 and 1 they are equal. Here it is 1/3, 1/3. They are also equal. So it will be a parallelogram. Now how to prove given points are collinear or not? In a triangle to prove, not in a triangle, if collinearity you are going to prove, this concept of slope is very ideal over there. To prove that points are collinear, you take 3 points. A is minus 5, 7. B is minus 4, 5. And the point C is 1, minus 5. Now, if you find slope of AB, this is going to be 5 minus 7 by, so this is minus 2. Slope of BC is what? So this is also minus 2. So ABC must be collinear as they have the same slope. Using this concept, you can find the value of K here. You find the slope of this point. Let it be A, this one B, and this one C. Just put slope of AB equal to slope of BC. Just to find the value of K if these 3 points are collinear. If they are collinear, slope of AB must be equal to slope of BC. I am using that concept. What is AB slope? Minus 1 minus 2 by 2 plus 3. 4 plus 1 by K minus 2. So K minus 2 going to be equal to 5, 25 by minus 3. So answer is 2 minus 25 by 3. This is minus 19 by 3. Alright. So this way you can solve problem based on slope. Now suppose a question arises this manner. What is, if 3 points are given to be collinear, what is the, suppose I am taking this problem that where A0, 0B and XY collinear and they have asked you to prove something. How to proceed? If these 3 points are collinear, prove that X by A plus Y by B equal to 1. How to prove it? To prove collinearity, to use collinearity condition, we will be using the same slope. Let us take this point. Let us take this point as A, this one B, this one C. Since slope of AB equal to slope of BC, therefore what is slope of AB? B minus 0 by 0 minus A. What is slope of BC? Y minus B by X minus 0. If you compare, it is Bx. Therefore AY plus Bx equal to AB. By AB equal to 1. So X by A plus Y by B going to be equal to 1. This way we can use the concept of slope to prove collinearity of 3 points. Now another kind of question also may arise. The vertices of triangle given, find the slope of, I am just solving one part for you. This is say 2, 4. This is minus 3, 1, and this point is 4, comma minus 7. They have asked you to find slope of the line joining B to the midpoint of AC. You take this one M. So this midpoint you can find easily. 4 plus 2 by 2, that is 3, and minus 7 plus, that is minus 3 by 2. Now slope of BM you need to find. Median means it will divide this in two parts. No, that's why we found the midpoint. Now slope of BM you need to find. This is y2 minus y1. Anyone, x1, y1, anyone, x2, y2, it doesn't matter. So this will be minus 5 by 2 by 6. Answer is minus 5 by 12. Alright.